What's up, everybody? We're going to get into one of the last things we're going to do all year, which is having to do with permutations and combinations and probability and combinations of different things we can do. And we're going to start with the fundamental counting principle, which is basically how can you figure out how many different options that you have. Okay, now this part up here, I don't really love the way this is said, but if M decision can be made M number of ways and decision N can be made N number of ways, and the two decisions can be made M times N. Again, I don't know that that's necessarily the easiest way to say it, but once we get into a problem, it'll make pretty good sense, right? If you've got 3 different cone sizes, 15 flavors, and 8 toppings, and you want to choose 1 flavor, 1 cone, 1 topping, then that's just 3 times 15 times 8. That's it, right? So if you've got 3 different options, you want to pick one of each, you just multiply them together. I'm going to go to Desmos. I'm going to do 3 times 15 times 8. Oh, and there you go. 360. That is how many total options we have to make this type of ice cream cone. Now, let's change the question up a little bit and say if you can only choose 1 flavor and 1 topping, but let's make it 2 toppings. So if you're going to make it 2 toppings, then you've got 3 different cones, 15 flavors, 8 toppings, and you can choose from 8 toppings again, because now you want 2 different toppings. And so you need choice 1 and choice 2. So it's 8 choices here and 8 choices there. So we would go over here. We would just do times 8. And we would have almost 3,000 different choices now. And let's say we wanted to make one more change where we want 2 toppings, but we want no repeats, right? Because where it is now, let's say one of our toppings is sprinkles. This includes where we get, a large cone with vanilla with sprinkles. And so this doesn't really make a ton of sense if you're going to get like double sprinkles. Although I know there's some crazy kids out there who probably love sprinkles so much. Sounds like a dream. So if we don't want any repeats, we need to change this 8 to a 7. Because whatever one we choose from the 8 is going to have to go down to a 7 because we're going to eliminate that, right? So it might be small vanilla with Oreos and sprinkles. And this 7 is like taking away the Oreos from the 8 that we used to have. So this number would be smaller. We would need to go back to Desmos. We would need to change this 8 to a 7, and we would have only 2520 now. So that's just a quick walkthrough of how you do these different things. The Virginia license plate consists of 3 letters followed by 4 digits. How many different license plates are accessible? Okay, so 3 letters. So if we've got letter, 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 number, 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 well, that would be 26 options, 26 options, 26 options, and then 10 options, 10 options, 10 options, 10 options. So we would need to go to a calculator somewhere and do 26, 26, 26, 10, 10, 10, 10. That is how many different possibilities we have in Virginia for a standard license plate. That's 175,760. Actually, it's a million. The answer there would be 176,760,000. I can't remember what the number was. 17576. 17576. Whatever. That's the idea. Just taking this, multiplying it by what you got, going from there. Science test with 12 true or false questions. How many different ways can you answer these questions? So this one's a little tricky. We've got 12 true or false questions. So a true or false question would be two choices, 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 two choices. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 questions where you have two choices on each. It's either true or false. So if we go and we type this into Desmos, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we multiply all of these together, I wanted to start there. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've messed this up somehow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. 4,096. Now, you know what this means is that if you were going to try to guess and get all 12 of these questions right, there's 1 out of 4,096 chance that you're going to get the right answer, which is a pretty low, or when I say get the right answer, I mean that you're going to get every single question right. So yeah, it's a pretty low probability that you're going to guess 12 true-false questions right in a row. Sure. Now let's go to factorial. So this is a big part of what goes on in the math here that we don't see. So this is going to be something that looks like this, 5 factorial, which would be 5 times 4 times 3 times 2 times 1. This is the multiplication of all natural numbers from n to 1. If we think about this as being n factorial, like whatever your number is. So 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, if you go to Desmos, 9 exclamation mark will do it for you. Okay, 362,880. 362,880, and that's how you do a factorial. So you can simply type this into Desmos. Now, these are kind of an interesting way how these work in math, because 8 factorial is the same thing as this without the 9. Because here it is, start at 8, go to 1, multiply them all together. And so technically, if we wanted to find this, we could start here and just divide this number by 9. Take away the 9 from 9 factorial, and you get to 8 factorial. Anyways, all this stuff is a little weird. It's not that hard. You just type it in Desmos. Worth looking at, though, is 0 factorial, which happens to be 1. That's just one of those things, guys and girls. I don't know. Just deal with it. 0 factorial is 1. That's just how it goes. So we get to permutations. In permutations, there's a big formula, okay? I'm not even going to show this formula to you guys. What is important is that it's an arrangement or lineup of objects in which order matters. Now, N being the total number of objects that are available and R being the number of objects to use for the arrangement. Here's what I mean by that. If we go to number 6, it says that 7 students are competing in a geography B. How many ways can they finish first, second, and third? So here's what we're talking about. N is the total number we have, which would be 7, because that is the, is the total. And then the R is how many we're going to choose. So we're going to choose first, second, and third. So the R would be 3. So this would be 7 total. We need to pick 3. Now what's important here is that, the order matters whether we've got first, second, third. So for example, if we've got Jimmy, Tommy, and Lacey, that is a one combination here, Jimmy, Tommy, Lacey. But if I got Lacey, Jimmy, Tommy, that is a totally different option. So that's why order matters Anyways, what we need to type in is simply 7 in PR 3. Okay, that's going to make our N 7 and our R 3. Now, all we got to do is know how to type this into Desmos. So we go to Desmos, X. We're going to go to Functions. We're going to go to Miscellaneous. I don't necessarily see it in here. That's because it's actually in the Statistics category. We can see the NPR right here. Now, the way we're going to type this out is 7, 3, where our N is 7 and our R is 3, and it's going to tell us the answer. 210. You know, it's not any harder than that. Emily is taking 4 classes this semester: American History, Algebra 2, AP English, Chemistry. How many ways can these 4 classes be arranged? So, how many total classes is she taking? 7. How many classes are we choosing at a time, right? So are there any classes that we're not using? You know, up here there's 7 kids, and we're only going to choose 3 of them at a time. We're going to leave 4 of them out. Up here we've got, oh, I've written 7 there. Over here we've got 4 classes, and we're going to have to choose all 4. And so what we've got now is NPR 4, 4, because we have got 4 classes and we're choosing all 4. And so when we type that in, NPR 4, 4, you can see the answer we get is 24, and we're cruising. Now we've skipped this little bit up here, the important shortcut of NN. In other words, if you're choosing the same, if you've got 5 options and you need to pick 5 options, and that's what we just had down here. NPR 4 is the same thing. You say it's 4 factorial. Okay, so if you've got 5 kids and you need to pick all 5 kids, you can do a little bit of a shortcut in that this is n factorial. As far as I'm concerned, though, you don't really need to do this. You know, this is so easy. Just might as well do that. But anyways, this shortcut does work. I just don't really use it very much. Let's do these last 2 questions. 16 players, where we need a 9-player battering order. Okay, that's fine. That means N is 16. That means R is 9. That means we just need to type in PR 16, 9. And we go to Desmos. On there, NPR 16, 9. We're going to get a huge number. Wow, 9 zeros is going to be billion, right? So this answer here would, how many ways could we do it? 4 billion, right? A whole bunch. This can get out of hand really, really quickly. If there's 28 students in his homeroom, how many ways can he elect a student council representative and alternate? So that tells me that there's 28 total, and that we need to select a student council representative and an alternative. So there's only 2 kids that we're selecting at a time. So this would be NPR 28, 2. The answer would be 756, which again, it's a pretty big number if you think about it. Now we've skipped number 5. Number 5 is asking us how many ways can we arrange the letters in the word dinosaur. The way that you do this for any word scramble is that, and you might want to write this maybe, word scramble. It's going to be your total letters factorial. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So dinosaur would have 8 factorial letters, and 8 factorial we can calculate really quickly. 8 factorial, 40, 320. 40, 320. Now, this isn't very hard to do. Now, my last name is Collier, and you know, we can rearrange this. We can rearrange it into Ricellol, right? Let's see. Rearrangement. So there's two different rearrangements. Now, if I swap these two letters and I get RICE and I've swapped it out, so I've got L and L, all right, and I've swapped these two letters, it's still the same thing. Okay, so we have this issue of we need to actually eliminate this one because it's the same thing. Even though we swap these two letters, it's the same thing. So the formula is actually the total letters factorial divided by repeats factorial. Okay, to do a really quick example, one that you'll see on a test almost guaranteed, right? We've got Mississippi. How many different ways could you reorganize Mississippi? Well, Mississippi has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Mississippi has 11 total letters. And then how many repeats does it have? Okay, so it's got 1, 2, 3, 4. It's got 4 S's, so we put 4 factorial down there. It's got 1, 2, 3, 4. It's got 4 I's, so we put 4 factorial down there. And then it's got 1, 2 repeated P's as well. And then, of course, we've got the M. The M has no repeats, so we don't need to put anything in the bottom. We do need to type this in. We go to Desmos. We do a fraction. We do 11 factorial over 4 factorial, 4 factorial, 2 factorial. And that's the answer, 34,650. It's pretty interesting. You know, you can calculate exactly how many different ways you can reorganize Mississippi. And, you know, this includes, you know, Mississippi. There you go. There's a rearrangement where I swapped these. Mississippi is a rearrangement, right? There's one of them. So here we go. Permutations with repetition. We've got automobile. Automobile has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 factorial divided by, I've got O, 2 O's. I've got only one A, only one U, only one T, only one M, only one B, only one I, only one L, only one E. So that's it. You type it in, you get the answer. Okay. How many different ways could we do disappear? A little spooky. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 9 factorial divided by. I've got 1D, 1I, 1S. I've got A, 2 factorial. I've got 2 P's, 2 factorial. I've got 1 E, 1 R. We type this in, we get the answer. Cool. Moving along, we get to combinations, which is just a group in which order doesn't matter. NCI, I'm not going to give you the formula. If you noticed earlier, when we were doing Desmos, and we were in functions, there was an NPR, but there's also an NCR. Okay, and so when we're doing combinations, if she's got 16 friends and she needs to choose 5 to be bridesmaids, the NCR of 16, 5 would be 4,368. Now you're probably asking yourself, okay, I get that there's 2 different buttons, but what's the difference? Okay, if I do NPR 16, 5, notice how there's a lot more combinations for our permutations than there are for the combinations. The difference between these two is that for permutations, the order matters. In other words, this would be 16 friends where I'm going to rank my 5 favorite friends from 1 to first, right? So it might be, you know, girl A, B, C, D, E as my top 5, where A is my favorite and E is my 5th favorite. Or it might be, you know, B, C, D, E, A. That would be a totally different totally different permutation because those 5 are in a different order. You know, it might be C, A, B, D, E. That's a different permutation because I like C the best in that one. Whereas my combination is where basically once I choose those 5, I like them all the same, right? So since she wants 5 bridesmaids, once she picks A, B, C, D, E, they're all bridesmaids. They're all the same, okay? It's like once I got those 5, they don't have any order that matters. It doesn't matter whether I say A, B, C, D, E or whether I say E, D, C, B, A. It's still the same 5 girls. It's still the same group. Group does not, or the order doesn't matter. So if there's 24 kids in his class, how many ways can he choose 8 to come to the birthday party? Again, this is going to be in CR, and the reason is those 8 kids coming to the party, they're not ranked in any way. The order doesn't matter. We don't care who gets the first invite and who gets the last invite. They all get to go to the birthday party. So, you know, that would be 25, 8. I think it was 25, 8. And then, nope, 24. And then we'd go from there. 7, 3, 5, 4, 7, 1. 7, 3, 5, 4, 7, 1. Now what we're going to do is we're going to move on to this worksheet because I don't think it's a great way to just keep typing these in. Okay, the difficulty here is we don't know whether we have a permutation or a combination. Okay, now we'll start with the word scrambles. Okay, we know that the word scrambles are permutations. There's 2 of these. We know they're permutations because the order has to matter. If the order doesn't matter in a word scramble, you're in trouble. Okay, our word scramble, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. We've got 9 total. And how many repeats do we have? No, 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 no. Then we've got 9 individual letters with no repeats at all. So that means we don't need to divide it by anything. It could just be 9 factorial straight up. We already did this one earlier in the class, but we'll do it again. 9 factorial, 362,880. Sure. 362,880. Coming down here, Indianapolis. Okay, Indianapolis has 1, 2, 3. Let me put that dot here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Indianapolis has 12 letters. How many repeats does it have? It's got I. So it's got 3 I's. It's got in. So it's got 2 N's. It's got A. So it's got 2 A's. It's got let's do orange. 1 D, 1 P, 1 O, 1 L. We've already done the I's, 1 S. Okay, there you go. You're going to type this in Desmos, get the answer. 12 over 3 over 3 over 2. Fraction. 12 over 3 over 3 over 2. Oh, 2, 2. 12, 3, 2, 2. 12, 3, 2, 2. And the answer would be 19 million. 19 million different ways you could rearrange the word Indianapolis. Pretty crazy. Pretty crazy. Now, the rest of these are going to be a little tricky. Okay? We need to decide if they're a permutation or a combination. And this is a really good directions up here. A permutation is an arrangement with a specific order. A combination is a group with no specific order. Okay? So, if we've got 30 total candy bars and we're going to choose 4 candy bars. Okay, how many ways can 4 candy bars be chosen from a store that sells 30? Is this considered an NPR or an NCR? Okay, think about the R. Think about the 4 that we have. Okay, are we going to take these 4 and are we going to rank them? Are we going to put them in an order? Are we going to organize them? Or is it just straight up 4 candy bars? And since this one is just telling us, hey, grab 4 of them, don't organize them, don't rank them, just, hey, grab 4, it would be a combination. Okay, so that would be 30, comma, 4, and that would be of an NCR if you're doing it on Desmos. Now, number 2 is always one that's a little tricky for kids. How many ways can 13 students sign up for lunch? So if we've got 13 kids, how many of them are going to go to lunch? Well, all 13 of them need to go to lunch to eat. And then is this, hey, just grab the 13 kids, or is there something important about the order of the 13 kids or the ranking of the 13 kids, etc.? Well, since this question is asking us how many ways can 13 students sign up for lunch, they're asking us about the order of the kids in line. And so this would be a P. This would be NPR 1313. And if you remember, that's the same thing as 13 factorial if you have the same in. But again, I'm not really worried about that. How many ways can you choose 2 books from a shelf of 40? Okay, well, we've got 40. We need to pick 2. Are these 2 just 2 random books, or do they need to be ordered? Okay, all we need is 2 books. It's a combination. NCR of 40, comma 2. How many ways can 12 swimmers finish first, second, third? So we've got first, second, third. Once we get those 3 winners, are we ranking them? Yes. Okay, we are ranking them because they're going to get first or second or third, right? If we're going to rank them and we're going to have Alex get first and Nick get second and Grant get third, that's totally different than if we have Nick get first and Alex get second and Grant get third. So we need those in PR to keep those different options available. So here we go. Miss Sullivan is going to choose 2 students from 27 to help put away calculators. That is a combination. It's a combination because once she picks those 2 kids, it's just 2 kids. They're not being ordered. They're not being organized at all. For 7, if you have enough tickets to play 6 different games, but there's 14 total games, well, just a combination because it's not asking you to take these 6 and to pick them in order. It's not asking you to rank them. It's just give me 6 games. 8. How many different ways can 9 trumpet players in the marching band line up? Okay, we've already seen this one. That's a permutation. That's an N9, R9. That's going to be the same thing as 9 factorial, but again, I would just type it in as NPR 99. 7 students work together on a project. How many ways can their teacher choose 4 to present the project? So once we get these 4, it's just a combination, okay? The 4 of them, there's not a captain or it's just straight up 4 kids in a group. They're not ordered. They're not that important. Finishing this up with 2 more because we've already done 11. 11 players on a hockey team. How many ways can we choose different positions? Left, center, right wing. This would be a permutation. I'm going with permutation here because, you know, again, if we've got A, B, C as our left wing, center, and right wing, I could also choose this as, you know, B, A, C, and that's a different starting lineup because I've got a different left wing. And finally, 26 goldfish. How can Ben choose 5? It's going to be a lot of responsibility for Ben. Hope he's ready for all those goldfish, but that's going to be combination, right? He's not picking, you know, rank the 5 goldfish or anything like that. He's just grabbing 5 of them and going with it, okay? So this would be in CR 26, 5. The main thing with NPRs and NCRs is think about that group. Once you're thinking about that group, is it just a group? Okay, is it just a couple kids? Is it just 5 goldfish? Is it just 2 books? If it's just 2 books, then it's a combination. Now, if you have that group and you need to then sort that group, or you need to organize that group, or you need to rank that group, okay? For example, like number 5, first, second, third. Okay, that's going to be a permutation. For example, like number 12, where we need to order the students in line, okay? For example, like number 18, where we have different positions. All of those things would make you a permutation, which would give you a lot more different ways to show up, because we'd have ABC, BAC, CAB, CBA. We'd have all, like, even if with just ABC got picked out of 18, we'd still have a bunch of permutations within those 3. Anyways, that's permutations and combinations. Watch this video. It might be one you have to watch twice. It might be one you have to kind of watch again or think about again, just because that permutation combination can be a little tricky to get a hold of, but it's not too bad.